This is our third webinar series on a Friday, where again, just as a team, we're taking a different approach this year to come together virtually on these bi-weekly Fridays. And we of course are inviting anyone else who's interested in this certification to come join us at this table in a very casual, flexible way. So if you missed those earlier sessions and you want to watch them, we have them recorded. You can put a note in the chat. Caitlin can take a note of that. She can send you details from our past recordings. One of the things we did on the very first session, where we sort of did a zoom out on the PCNSE certification, was identify the main landing page, which I have up on the screen now. Just going to highlight a few areas that we're likely to reference as we go through and digest the content in domain 2. So the Caitlin could pop in the link to this page, or I can, Caitlin, if you don't have it handy. But when we browse to the PCNSE page, there's many great things on this page. There's many great resources. What we're going to do is click on a few and highlight them. We're going to click on the blueprint section, which is essentially a table of contents style outline of how the exam is broken down, and the study guide, which is an expanded version of content related to those exam domains. Includes other things such as sample questions. So going to the blueprint, today we're digging into domain 2. It's described as basically deploy and configure core components. This is going to be foundational items related to the Palo Alto Next generation firewall configuration. The first domain was more high-level foundations, grounding concepts. We're starting to get a little bit deeper here into key components, and those are in some cases broken down. So with that being said, I'm going to just stop sharing. I think what we did last time, and we're going to do the same thing today, is really do a bit of a team approach where we have basically taken the subdomains, the tasks is what they're called just on the blueprint, and we've somewhat divided them amongst our team. So I think, Jawad, you were going to take the first wave of some of those core components. I'll hand it over to you and stop sharing the screen here.
Thanks, Stefan. Good morning, everyone, and thanks again for joining this session. I'm gonna share my screen. You guys see my screen? First slide there, 2.1.
Yes, we can.
Okay, yeah, so that's the first section in the study guide for this one. Talks about the interface management profile. So as most of you are probably aware, the firewall comes with the dedicated management port for access, like to access the GUI or the CLI. But this interface management profile gives you also the opportunity if you want to do the same through the in-band or data interfaces. So to access the firewall again through the data interfaces, you have to configure an interface management profile. For example, at a minimum, if you want to ping the interfaces, you have to check in the ping on the interface management profile and then attach that to the interface. If you want to access it for management purposes, like the GUI or the CLI, same way you do with the management interface, then you check other services like HTTPS, SSH. Those are the common ones usually. Other uses of basically management services on in-band interfaces would be things like if you're setting up a captive portal or authentication portal, then you'll enable the response pages here. If you want to share or distribute user information or timestamps for authentication, there's user ID, and there's other options also to check in on those profiles. The other thing that this section talks about is the SSL profiles. So this is basically allows you to configure a certificate and then define minimum version. For example, we know anything less than version 1.2 TLS is not secured. So if you want to basically strict access just to higher or secure versions, then you can set this through an SSL TLS service profile. And then use cases for this would be like GP portal, GP gateway, authentication portal, even access to the management. Also, you can configure that SSL profile as well. That should be all in this section 2.1. Any questions before moving to 2.2? Okay, 2.2 is security profiles. So this is a bigger section, definitely. This is the core of firewall functionality. It covers all the threat detection and prevention capabilities of the next-gen firewall. So just few things to highlight first about security profiles. It requires licenses to activate different threat prevention. So for example, there's a threat license that covers antivirus, anti-spyware, and vulnerability protection. Then there's a separate license for URL filtering and advanced URL filtering, which we'll talk about. And there's a third license for wildfire protection. So this having the licenses allow you to activate those protections on the firewall and then get all the updates for those engines. The security profiles work as they are stream-based. So as packets flow through the firewall, they're being inspected on the fly firsthand. The firewall doesn't wait to construct the whole file, for example, before scanning. The scanning is happening in line on the spot. Very important feature. Also, the security profiles are applied at the policy level. So it's not like you turn it globally and then it's applying it to all traffic. You have specifically to apply those profiles through the policies, which give that granularity. So maybe you want to apply strict profiles to specific, portion of traffic, but maybe do alerting on other policies. Like, for example, SMB, FTP, those are ones come to mind, which might have some impact when you turn on a lot of prevention. So might require some consideration about how to configure security profiles around those protocols. So having that, so basically when you have security policy and after all the match happens through the source, destination, and application, and given this is an allow policy, so traffic is being allowed through, this is when you want to inspect for threats, right? So make sure, yeah, like if it's a deny policy, there's no point of configuring security profile on that. So allow policy, then you can choose to define a group, which is basically grouping the different security engines or profiles, or you can individually select those in that section. The security profiles to be configured include all these protections, as I mentioned, and we'll go through each one of them. Starting with antivirus profile. So this type of profile protects against common malware like viruses, worms, and Trojans. And I think the thing to understand with each of those profiles is what kind of protocols is trying to protect, and then what actions we have available to apply. Those actions range basically from providing ability to do detection and then to doing more of prevention. So under antivirus profiles, so we have the different decoders or protocols that this engine basically scans for. Those includes FTP, HTTP, SMTP, and others. And then the actions would be for detection would be either allow alert, understanding the difference. Allow is basically just allowing the scanning to happen, but is not recording any logs. While alert is achieving the same thing, it's detecting only and scanning without doing any prevention, but creating a log for in case of detections. More of the prevention actions would be the drop, reset client, reset server, and reset both. And the difference is basically drop is dropping or blocking silently that session or once it's detect a virus. While reset, it's basically sending a reset packet. And you can choose either to be towards the client or the server or to both sides. Most common one would be the reset both action. Moving on, anti-spyware, that's another threat profile there or security profile, which protects against compromised hosts that are trying to phone back, type of like C2 channels or beacon, like Cobalt Strike is a very common one. And so again, same type of actions that range between detection and prevention available for this one. Usually, like if we talk about best practice, recommendation is to block reset both on critical high and medium severity anti-spyware or spywares, and then alert on like low end informational ones. In terms of the additional action here is the block IP available for the anti-spyware, and this is in some type of attacks, you can choose just to block that IP for a certain period of time rather than just resetting it. Part of the anti-spyware profile is DNS protection. I think that's a big part of it. DNS is used by every organization. It's clear text, it can carry data, so it could be abused by bad actors, and it's definitely been abused in many different forms. So there's all kind of DNS attacks like DNS tunneling, DNS infiltration, zone hacks, dorm DNS used by bad actors. So originally, Palo Alto had DNS sinkholing to protect users going to malicious sites and detecting that and then blocking or sinkholing those users. And recently, they deliver now a cloud-based DNS protection, which is the advanced DNS security, and that's part of the anti-spyware profile as well. This one provides protection about unknown DNS or new DNS that are not part of the local firewall definition or signature base. So it would send it out to the cloud, do more of machine like advanced kind of analysis on it, and comes back with basically a verdict on that domain, whether it's benign or malicious, and then inline basically provide that protection based on the action again you've defined for the different protections available under DNS security. Okay, moving on, vulnerability profiles. So that's definitely an important one there. It's more of the IPS, IDS protection. So that protects against known exploits or known vulnerabilities in different softwares and applications. And when a client is connecting to those and it detects, that there is potential exploitation of those vulnerabilities, then you could also again provide an action of either detection or prevention under this profile. And pretty much same actions can be applied to this. This is the one like we usually that could produce the most false positive. So starting with more of starting with more visibility, alerting initially on this one, and then going through an analysis period and fine tuning would be the best approach before going into like more of prevention on this one. Another profile there, again, it's an important one, is URL filtering. It's used by a lot of our clients, and this protects basically and controls access to web. So provides that web filtering capabilities and protection against like phishing sites and malware sites, and even like from policy perspective, if you want to block like adult and other unappropriate material, this is all can be controlled by URL filtering. Um, Again, sort of that evolution and all of these capabilities. Palo Alto, I think they started originally with a third-party URL filtering solution, and then they introduced their PanDB, the Palo Alto database, again on the firewall, and now they're extending this into the cloud. So there's also an advanced URL filtering added to this, and we'll talk about those in the next slide. Just one note about configuring of URL profiles. So there's predefined categories that comes part of this, and then you can set the action to be, again, for visibility would be alert, for prevention would be block, for like the categories you want to block on, and then there's also an option to continue. So a response page would pop up, and the company can customize this response page with like a warning and why it's warning the user not to go to this site, for example. And then the user can choose either to close the site or to continue browsing. In addition to those predefined categories, also there's a capability to create custom URL categories. So you can create your own custom URLs, whether for whitelists or blocking purposes. Part of this URL profiles, again, relatively newer feature is the credential phishing prevention. And this one is basically providing protection about against users potentially submitting corporate credentials into a malicious website or a phishing website. And this is configured under the user credential detection, and there's different options here. This is an integration or coordination with the user ID feature. It's gonna compare basically the username from the Active Directory to the username that's being submitted. And if it matches, if it's a corporate username, then based on the action you have for the user credential submission under the categories here, it could be a block or an alert, or again, a continue to warn the user from browsing to that website. So user IP user mapping is basically just checking the username. User group mapping is checking it against a user group, and then user domain credential filter. That's basically gonna work with the user ID agent on the domain controller to check both the username and the password. So different options there, just on what level of check it should match, or what level of match basically it should do. Then the advanced URL that's been added in the PanOS 10. So this is the cloud capability where for unknown URLs that the firewall hasn't seen before, doesn't have it in its database, then it's sending it to the cloud for machine learning analysis, real-time analysis for basically around phishing detection, which becoming very complex and advanced. So it provides that additional capability to detect phishing sites and real time provide back verdict to the firewall to, again, take an action of a block or alert on those sites. Moving on, the next one is file blocking profile. This is basically to provide an opportunity to block or alert on file types based on file types. And yeah, the action could be to block on certain high risk or dangerous file types like PEs or EXEs or others, and then alert on other file types for additional visibility. Another one, there is data filtering profile. This is a light DLP, like it has basic DLP capabilities and basically to prevent sensitive information from leaking. So this is configured through the data patterns, and this could be like a predefined pattern of a certain string, or it could be a regex, and things like the predefined patterns would be things like credit card series information or serial numbers, etc., etc. So that's data filtering. And then Wildfire, as you're probably aware, this is the initial sandbox cloud threat prevention from Palo Alto. And that, as I mentioned, this requires a license in order to be able to, get the full capability. I think it's important for the PCNSE to understand like what type of files can be uploaded to the Wildfire for that kind of additional analysis. And then this works in conjunction with the other security profiles. Like once the Wildfire comes back with a verdict, is gonna update like the antivirus or other profiles through which you're gonna apply the actions to those files. Just going back to this session, I want to mention that there are tools from Palo Alto that will help basically uh, deploying best practice configuration for the security profiles. And this would be the Iron Skillet and the best practice tool. And like for anyone who's basically the Iron Skillet is pre-configured day one best practice configuration templates that can be downloaded from the site and loaded to the firewall to provide, like if you want to have prevention, right away from day one, they have best practice prevention templates, or if you want to have more, other templates are available as well for both Panorama and the firewalls. And then BPA is the tool basically we use in our managed services to assess the configuration and then identify gaps in the security profile configuration and propose best practice or updates that can be applied to the configuration basically. Also, I would like to mention that decryption is key in order to take advantage of all those capabilities. Without decryption, it will be hard for the firewall to apply some of the detections as for encrypted traffic. So a prerequisite would be decryption as in order to be able to take advantage of all those prevention capabilities, basically.
Yeah, there's a lot there, isn't there, Jawad? It's a very important feature of the next generation firewall, and it has, as they continue to develop the PAN-OS and the firewall itself, they continue to add new features and new subscriptions there.
Yep.
Couple quick questions for you,
Certainly.
Joab, just because I think it is appropriate. I think we're sort of halfway through. We got through the sort of the security profiles, but I don't think anyone would deploy a firewall without deploying some aspect of the security profiles, correct?
Yeah.
And
Yeah.
some of them, maybe data filtering is probably very rarely used, and others such as URL filtering, threat prevention, wildfire are very commonly used. So there's a mix there as well.
Yeah, agreed. Data filtering and even file protection mostly turned on
Right.
in alerting. More of prevention on, and commonly used would be antivirus, anti-spyware with DNS, and vulnerability in conjunction with wildfire, definitely to provide that
Right.
cloud machine learning capability as well.
Right. Awesome.
Okay, so moving on to 2.3. So everything we talked about with security profile and threat prevention is gonna apply, I would say, later in the packet life. So after a session is established and policy is matched and packets are flowing through, this is when we want to start scanning the packets as they go through for, viruses and vulnerabilities and other things, right, that we talked about. However, there's some attacks that happen very early in the life of the session, even like when we're doing the TCP three-way handshake that early, right? And for those, we've got the zone protection profile to protect us against those type of attacks. And the zone protection profile is configured in a different place under the network tab and on the firewall. And it has 3 or 4 components into it. One is the flood protection. So this is like SYN attacks. There's UDP attacks. There's ICMP flood attacks. So this is all configured in the flood protection here under the zone protection profile, and understanding the different thresholds here. So we've got the alarm rate. This is just alerting when it hits that threshold. And then activate is when we're activating that protection capability at that threshold. And then maximum would be the maximum allowed rate for that threshold before it starts dropping all the subsequent packets. Again, this requires just baselining, understanding the CPS, connection per second, and throughputs and things like this in the environment in order to be able to hit like the good levels on those different protections. Reconnaissance protection is another one. This is protecting against scan type of attacks, like there's TCP, UDP scans, and then there's host scanning. So if there's someone trying to scan from the outside your IPs or servers, then you can set thresholds again and intervals to alert or block on those scans. Very useful, especially on the external zones, I would say. And then there's all kind of packet-based attack protections for TCP and IP mainly that we've commonly, again, configured for our clients on, again, mostly on the external facing zones. And things like spoofed IPs, malformed IPs, and overlapping TCP segment. TCP SYN was data that's, like blocking on that. TCP timestamps and others could be configured as well to provide that additional protection. Then there's a protocol protection. This is an Ethernet SGT protocols. This is for non-IP networks, like even protecting against Ethernet type of or layer 2 type of attacks could be configured in the zone protection profile as well. So zone protection profile applies mainly on a zone level. So it's not specific to a server or an IP. It's gonna basically apply to the whole traffic on a zone. But if you want a flavor of that on to protect specific service or services, there's the DOS protection, which is very similar in terms of protecting against flood type of attacks. And basically, you can also define a maximum number of sessions hitting that server or services. Then this is configured under DOS protection. And the main thing to basically understand in the DOS protection configuration is the type. So there's the aggregate and there's classified. So aggregate is gonna apply those thresholds or rates to the whole group that you have defined in the DOS policy, while classified is gonna just apply it to a single source or single server. Yeah, that covers the first three sections here. Any questions before I hand it back to you, Stefan?
No
One I'll
questions,
throw
I'm
over.
impressed. I was
Yeah.
gonna say there's so much to dive in further there on like all the protections, like how they operate.
Yeah.
Like I know you're for the sake of time, you're not going into some details, obviously, Joab. I think you did a great job as just overview. But things like, you know, how do some of the protections apply, like random early drop, known as red, why why zone protection shows 000 as a source sometimes. There's lots of details there to go into. So if there's questions, yeah, there's more to this than just clicking the button.
Oh,
Sometimes
absolutely.
understanding how it operates is really good. So yeah, there is questions, definitely let us know.
Yeah, good point, Paul. And I'll say just from a high level, you guys can correct me if I'm wrong. It's potentially the case that customers don't use this type of protection, right? They may just not have it turned on, and there wouldn't be these preventions at this level. But it could be an opportunity to protect against some of these attacks. That Joab mentioned the best practices resource. We put some of those links in so you could browse there. There are prescriptions around these parameters as well. And like Paul mentioned, there's a lot of variables. Some of them very much depend on your environment, so it can be very complex. All right, I'm going to share out the study guide again here, and we'll move on to subsection 4. Give me 1 second. Okay, now I think the first element here is around HA. So what I'm going to do, if you guys can confirm you can see my screen, looks good, is basically, there's a lot of parameters around HA, but I'll say most of the implementations we deal with happen around one type of HA deployment, and that's called active passive. So when you look at the study guide material, they do get into details of active passive, and that's really what I want to touch on here. So we're familiar with network infrastructure and other firewalls. The HA constructs usually are a little bit different on a firewall than a network device. So on a network device, it's a packet in, packet out. There is no assembly from a so-and-so called connection or state. And HA can be much simpler. Active-active could be two devices just forwarding packets, and they don't really need to understand if those packets are related to other packets, they're good packets or they're bad packets. So when dealing with redundancy and HA in a firewall, there's always aspects of session state. In active passive, really, one firewall becomes the owner of the traffic and processes all the traffic. And this becomes much simpler because there is no other logic needed to understand parts of that session that might be in different packets are going to a different device. So in an active passive state, as an administrator, you will really manage the firewall, and most configuration items will be the same between those two devices. And when you apply configuration, most of those parameters are synced. And when a failure event occurs in an active passive implementation, usually all of the traffic will go to the new device and start flowing through that new device, including the IP addresses that might be on network interfaces and things of that nature. There are parameters which are independent. Obviously, management IPs and some of those aspects, you can still get to two devices, even though they're in an active passive pair. But most of the day-to-day configuration is synced and identical between the pair. So that leaves the question, and I just wanted to touch on it quickly. Well, what is active-active then, and why wouldn't you just use it? It sounds like it should be better than active-passive because I can use two devices and not one. And really, when you think about having to scan all of the packets within a session, Jawad just mentioned using a security profile and a rule, scanning all that traffic going through that one rule to that security profile. What actually happens in an active-active is traffic is forwarded back to the session owner in some cases for scanning. So it's almost a divide and conquer, but there's an extra layer of complexity in getting the right traffic to the right firewall. The only use case we've seen in our deployments is specific surrounding routing requirements, sometimes related to BGP, sometimes related to how customers have architected their network around the firewalls. That would promote a valid use case for active-active, but it is very infrequent. And I think if you don't really have a good case to understand why to use active-active specifically, don't use it. And operations will be simpler, more stable, easier to manage, and so on. That's not really doing it quite justice from a topic, but as I get ready to go to the next section, I'll just pause too and see if any of the team has any other comments they want to make on HA that I might have missed. All right. Further in this section, they get into bootstrapping and zero-touch provisioning. I'm going to touch on these from a very high level because, again, much like the active-active HA, we have not seen most or all of the firewall deployments leverage these features. These would be features that you would require if you found yourself in an administrative seat having to deploy hundreds, maybe thousands of firewalls very rapidly, and they were maybe very identical or a common use case. In these aspects, bootstrapping and zero-touch provisioning could be amazing features to leverage. The zero-touch provisioning really, and actually I'm going to scroll to a graphic, a picture that talks about all of these things coming together. But essentially, the bootstrap aspect allows you to jumpstart the device with a preloaded configuration and an ability to phone home to attach to a device like Panorama for management. So there's a lot of aspects. I'm not going to get into them here just to respect everyone's time and make sure we can get through the content, but understanding just the concepts, what might be required to achieve those use cases is likely to be on the exam. All right, I'm going to keep moving down. I know, Paul, due to the way the week was, I'm not too sure if you want to jump in on any of these, but I'm going to keep taking them unless you holler and say, I got it.
Yeah, feel free to throw something to me, Steph, if you want, or I can answer questions as they come up in the chat or something. But
sure,
so far it's been pretty
sounds
quiet.
good. Excellent. Okay, so we talked about HA, we talked about zero-touch provisioning from a high level. We're going to go to sort of the role-based access control. I'm going to talk really high level from this aspect as well. I found it interesting reading through and preparing for this section. The role-based access control, first off, really, I found it helpful to think of it as sort of three methods, three doors or methods to get into the firewall. There are the, obviously the web interface we're all used to is a method to administer the firewall, the most common. There is the CLI, which everyone would know if you're any type of network or firewall administrator that's there. And the third is there's the XML API interface. So we find out, whether it's a predefined template or getting very granular with some of these settings and adjusting roles. I like to think of them in those three buckets. And then due to them being very different, the granular controls are different in nature. So on a web interface, you might be able to give certain accesses to the administrative page for someone or take it away. And for API XML calls, it might be a certain tree or a certain API call that the granularity is around. The other aspect I really wanted to highlight from a high level is really authentication. There's a variety of authentication types supported on page 90 of the study guide. One thing I really wanted to highlight here is obviously those administrative doors that I spoke of can leverage these authentication types, but also other features on the firewall can use those authentication types. So Global Protect, remote access, VPN can use these authentication types. Paul touched on our previous session, authentication policy. For inline traffic, I maybe want to authenticate a user to some degree, they can leverage these authentication types. So touches on the authentication from an administrative perspective, and then those constructs can be used outside of that as well. And I just wanted to mention that. I'm going to go to one last aspect here, and I think I'll be handing it over to you, Mohammed, to talk about some routing, NAT, and site-to-site tunnels. And I know VPN tunnels, IPsec VPN tunnels are everyone's most favorite thing to troubleshoot and configure in the world. So let's try to get there quickly. I'm going to go to the one page on certs here, just as a picture. So again, like I mentioned, the authentication sources are foundational. The cert store and cert management is foundational as well. After just running through this, I might just pivot to you quickly, Paul, here. You've had much more experience with this before handing it over to Mohammed. But long story short, if anyone's been familiar with a cert store in their browser or their operating system, it has to do with public-private certificate architectures. The firewall has a cert store and a certificate entity on it as well. It has default root certs it trusts. You can add and edit and modify root, intermediate, and entity-specific certs in the firewall. And they come into play for things like the SSL page when you browse to an administrative page of the firewall, and for other aspects such as SSL decrypt as well. Maybe pause here, Paul, let you add anything you want on sort of the foundations of how Paleto Firewall manages certificates.
Yeah, like you said, cert store. The other one to mention is the certificate profiles, is essentially certificate authorities you add to what they call a profile. The profile then can be applied to validate that a certain certificate being offered is signed by that signer or issuer, I should say. So right. For example, client certificate authentication, if you have a SSL VPN, you connect to it with your Global Protect client, you can actually validate a client cert is signed by an issuer in order to validate, for example, a computer device certificate or a user certificate. So that's another portion of this is client certificate validation by issuers, and obviously your typical web browser SSL functions, right? Whether that's Global Protect page or your firewall.
Awesome.
capture portal or anything else. Yeah.
Yes.
Yeah, TLS SSL profile is what that's called. And then certificate profile is when you're sort of validating a certificate being offered to it.
Excellent. Yeah, thank you for that, Paul. Wonderful. Like Paul mentioned, throw questions into the chat, unmute and interrupt. We're really flexible that way, but we will keep going just in the interest of time. I'm going to stop sharing my screen, Mohammed, and I'll let you get ready to talk about the routing aspects.
Sounds good. Yeah, I'll share my screen and I'll share the PCNSE guide as well here. You guys can see my screen? Okay.
Yeah, we can.
Awesome. All right, so diving into the routing section of the PCNSE guide. Yeah, just interrupt me whenever you guys have any questions. I'll just keep it at a very high level and also throw in some examples what we have done in real life deployment here. So Palo Alto does support static, dynamic routing, all of it. Starting from PAN-OS 10.2, they have introduced a new advanced routing engine. Not widely used today. It's really brand new. So what this offers is some of the route maps that you guys might be aware of from advanced routing features. Now you can control traffic through route maps. There's granular control on how the routing protocols are being redistributed between the routing domains. So yeah, you can turn this advanced routing feature from the management plane under the device management tab. So the only change I would say from advanced routing is, as I mentioned, some granular control on the routing. And now instead of virtual routers, now they call it logical routers. Aside from that, mostly everything is same. So Palo Alto does support virtual routers, which in turn means you can have multiple segregated routing domains within a single firewall. Looking at the routing a little bit in detail, Palo Alto does support RIP, OSPF, OSPF version 3, BGP, and multicast. So these are the features you can do in a virtual router instance. You can create a separate virtual router instance and add separate interfaces of the firewall to that routing virtual router. And that technically acts as a separate routing domain altogether. It's just the configuration of the virtual routers here. This just shows you different virtual routers here. Administrative distance and ECMP routing. Different routing protocols have different ADs. This is how you will prefer OSPF versus BGP versus static routes. ECMP routing, this is where you can have multiple routes to a single destination. Palo Alto can support up to 4 different multiple routes of equal cost. The benefits of ECMP routing is, of course, it will load balance traffic between the 4 routes here and also acts as a failover. If one of your routes fail, the other 3 or other 2, how many ECMP routes you have, will take over. Some of the route distribution here we can dive into. You can definitely redistribute OSPF into BGP, and any connected routes you have on the firewall, you can distribute it into the routing protocol. Few items that we have seen in deployments is where Palo Alto have 2 ISPs, completely dependent on static routes. So you will, create a default route to ISP1 with a default metric of say 10. And on the secondary backup ISP, you will create a secondary default route, change the metric to 100, higher the metric, lower the preference. The only caveat to this, and I would like to point out, is if the ISP1 goes down, the traffic will not fail over to the secondary ISP unless you do a path monitoring on that static route. Without the path monitoring, the static route will still be in route table, and it will still be trying to forward it to the failed ISP. Hence, you're having an impact on the network. So keep in mind, when you have dual ISPs on the Palo Altos, you can do 2 default routes with different metric, but make sure to enable path monitoring on the primary static routes. So it can be removed from the routing table as soon as it detects there's a failure of ISP1. The other section quickly is on policy-based forwarding. So policy-based forwarding comes into play where you want to change the default routing behavior in Palo Alto. The couple of use cases I've seen in real life is, how routing works is based on destination addresses. You can use PBF to, source the route from a source zone or a source address perspective. That's one use case where you want to inject, I want, 10 network to go out for ISP1 and network 10.20 to go out to ISP2. So you can, reference the sources based on your routing decision. And the other use case would be when you want to do a failover or when you want to change the destination from a default routing table. You're saying I have a default route that points out to from egress Ethernet 1/1, but I can use PBF rule to override that, and it's like, no, my default route will actually egress out of Ethernet 1/2. So that's another use case where you want to actually, modify your current routing behavior. You just use PBF. Here it just talks about what's the difference between virtual routers versus logical routers. It's essentially the same. Logical routers just, provides a little bit more granularity on your routing domains. Moving on to NAT here. So there's a bunch of NAT, different type of NATs are configurable in Palo Alto. You have dynamic IP and port NATing. So this is your typical hide NAT. These are the NATs you will use for internet traffic. So you're masking your source addresses to the Palo Alto's internet interface address. One thing to keep in mind is whenever you use a NAT policy in Palo Alto, you'll always require a subsequent security policy. Especially, I think it's a very popular topic that Palo Alto wants to point out in your PCNSE exams, or the pre-NAT versus pre-NAT IP and the zones. For an example, if you're using a destination NAT, they will ask you where will you put in the IP? Is it the post-NAT IP or pre-NAT IP? So you just have to keep in mind how Palo Alto processes this packet. It will always be pre-NAT IP in the security rule and post-zone. So let's talk about some source NATing. So this is where I was talking about the dynamic IP and port, dynamic IP. This is where you can have a reserved pool of IPs in the NAT, and it will be a one-to-one but dynamically assigned from source NAT to a destination NAT. Static IP, as we all know, it's a one-to-one NAT. No NAT policies where you want to override any of the NATing behavior. You can always put in a no NAT policy on top, saying I don't want to NAT these source and destination. U-turn NATs is another scenario where we have seen the internal clients needs to talk to a web server, but on a public IP address. So in this case, you will use U-turn NAT. So the traffic goes from the internal traffic out to the internet, back into the DMZ web server. But the U-turn NAT helps in a way where the DMZ web server actually does not talk. When it wants to return traffic to the internal server, it actually goes back to the firewall, which keeps the symmetry of the traffic and allows the firewall to process the traffic correctly. Without the U-turn NAT, the web server will receive the traffic and it will seize its route table. Is saying, oh yeah, it's an internal server. It will send it directly to the internal server, bypassing the firewall. And this is where you will see disruption in the traffic. So U-turn helps in that scenario. Let's move on to these are just traffic counters you can use in Palo Alto to see how many rules are being hit and at what time. It's a really good feature. Moving on to IPsec tunnels. So Palo Alto can definitely support IPsec site-to-site tunnels, the different type of tunnels. You can use remote access tunnels. Those are called Global Protect in Palo Alto's domain. For IPsec tunnels, you can definitely use OSPF or any other routing protocol within the IPsec tunnel. In the olden days where it said, IPsec tunnels are only limited to unicast traffic, no multicast traffic is able to traverse in it, or especially with the dynamic routing protocol. But in the later versions of the PAN-OS, you can actually traverse all your dynamic routing protocol through IPsec tunnels. The only thing you'll have to keep in mind is you'll have to configure the tunnel addresses so they become your routing termination point. So for the IPsec, there will be two aspects of it, right? Phase one, phase two. In Palo Alto, you will use IKE gateways. They will represent as your phase one, where it actually established the tunnel. And then your phase two will be your IPsec tunnels, where your actual data traverses when the tunnel is formed. This just shows you that IPsec tunnel different phases. As I was mentioning, IKE gateways is your phase one, IPsec tunnel is your phase two. Palo Alto does support both static peers and dynamic peers. We have seen some situation where site-to-site tunnels where one of the site, especially branch small sites, they do not have a static IPs. There are solutions in Palo Alto networks where you can support dynamic routing, dynamic IPs, where DHCP keeps changing the IP. But in those cases, you don't set up a tunnel on a static IP perspective. You set up a tunnel based on FQDN email. You can make up an email, any random email, and use the tunnel based on those email identity instead of just static IPs. The other useful thing we have seen in real lifetime deployments is IPsec tunnel monitor. Suppose you have two tunnels to a same destination. As earlier, I was giving an example of ISP1 and ISP2. So in that scenario, you'll have tunnel 1 on ISP1 and tunnel 2 on ISP2. Besides doing static path monitoring, on top of it, you can also do IPsec tunnel monitoring. How that helps is if tunnel 1 fails, it does not actually wait for your entire IPsec phase 1 to expire, which is typically 1 hour. With the tunnel monitoring feature, you can actually instruct the tunnel to fail over right after a configurable amount of time. So when you configure tunnel monitoring profiles, you will have two options: wait recover or failover. Wait recover, I mean, this wait recover usually we don't typically use. It doesn't provide any benefit unless you're using PBF rules or whatnot. But mostly what we have seen is failover. So this is where we can instruct a tunnel to see there's ping packets between the tunnel IPs. We can tell failover to say, okay, if I cannot ping the destination tunnel 3 times within 5 seconds, failover the tunnel or remove that tunnel routing information from my routing information base, the RIB table. A couple of neat features in Palo Alto's versus other equipments I've worked in the past is in Palo Alto, you can manually initiate a tunnel right from the Palo Alto CLI commands. You don't really need to actually traverse interesting traffic through the tunnel. In the past, we have asked clients, say, can you start a tunnel so I can monitor it on the firewall? But the benefit of these commands is like an administrator can initiate these tunnels phase 1 and phase 2 right from the CLI. We don't need actual clients to be testing the VPN tunnel. Some more detailed configuration Show VPN Flow is a great CLI tool where you can look at what's happening with the existing tunnel. Palo Alto 9.1 does support GRE tunnels as well. I won't go deep into GRE tunnels, but again, I would definitely prefer IPsec over GRE just from a security standpoint. But there are some instances where other endpoints are not IPsec capable. In those type of scenarios, we can definitely use GRE. This is probably the last topic of it. Oh. Yeah, if there are any questions, let me know. Otherwise, I'll hand it over back to you, Steph.
I'll pull screen stuff.
Awesome. Yeah, thanks for that, Mohammed. I know these have been pretty fun, but I know we've sort of joked, and as you were going through all the details, Mohammed, I thought we could call it the like Fire Hose Friday
I know.
session, because there's literally so much. And I've always thought of the next generation firewall but I'd like just your confirmation, Mohammed. It's a very capable router. It's a very capable NAT device and very capable IPsec tunnel device. But some of those parameters get very specific and can be complex. But that aside, there is a lot of capability baked in there, and I know we did not do it justice going over from an overview. But would you agree, Mohammed, with that?
Absolutely. Yeah, it's
Yeah.
a very detailed configuration in each of the aspects. I mean, we can take hours to explain every single
Yeah.
aspect of. Yeah, again, I appreciate if there are any questions, and if you have any problems even in the real deployment, let us know, and we can dive deeper into it later.
Awesome. Now Paul's helping me out. Go ahead, Paul.
Yeah, sorry, because I know the PCNSE, they like to touch on the NAT thing. Maybe just double click on that again. It's like pre-NAT IP, post-NAT zone in security policy. Mohammed mentioned it, but I'll just say it again because that's one that catches everyone. There's normally some sort of visual representation of an environment, and it'll ask you what is the security policy or what is the NAT policy you need to write, and knowing how that flows is pretty important. And I don't think you mentioned U-turn NATs either, Mohammed, but that's another one that's just understand kind of how U-turn NATs can occur if you're like an internal person going out and it U-turns through the firewall to come back into an internal service or to like a DMZ. It's another good one.
Yes.
Yep.
Yeah. Yeah, those are very good use cases, Paul. And I hadn't thought of that, but that is a very good recommendation to dig into those use cases. Jawad mentioned the packet flow. That is a bit at play at why maybe a certain IP address is in a security policy versus a NAT policy based on that use case. So great point. Awesome. All right, the next. Yeah. Do you want to talk to this, Paul? Because you're sharing it.
I don't mind. I'll just jump in. So service routes is basically a way for you to customize. By default, it uses to customize a route to or how to access or the source of the traffic to get to certain services that the Palo Alto uses. So consider like DNS, time, LDAP, all that stuff. So if you don't want to use the management port, which is the default configuration that kind of comes out of the box, it just says use management interface for all. Most environments are fine with this. Just consider that all your traffic is going to be sourced from Palo Alto's management interface. But if you have, for example, an interface that exists within a secure zone and the management interface doesn't transmit into that zone or can't access that zone, you may want to source it from an interface that is attached to that zone. And you can do that by basically changing or customizing either by destination or source. So for example, if you have a service that you want to target, like, I don't know, a radius connection, for example, you can actually target and change that to be your source interface, whatever that might be, right? Or your source address, and it'll pull that for you. Similarly, destination can be customized. So if you want to say, go to this destination, and when going to that destination, use this source address, you can do that too. So this is mostly for services that the Palo uses, or when the Palo reaches out for something, either by destination or service function, call it. And that's all I really want to touch on there, Steph. Was there anything else you wanted to go over on the service route?
No, that was wonderful, Paul, because that piece really wasn't in the study guide, but I'm like, a picture is worth 1,000 words in that one. To just see those services, everyone's going to maybe understand that a bit better. When looking at the study guide and the materials, I think they're really getting into the use case of in a virtual system or in other deployments where you wouldn't just use the management interface like Paul selected, you may need to select other interfaces used for data traffic. And they don't include this list that Paul has on, but when you get to look at it, you sort of understand exactly what the service route configuration is doing. So thank you for that, Paul.
No problem.
Yeah, I think we have one more aspect to cover, and then we can take a brief moment just to recap before closing out the call. I did just post in the chat, as we have done in the past, we're going to go long just to make sure we can get to the end. For those of you that have had to drop, if you have, I know we'll make sure to send those recordings to you. And again, if everyone's still hanging on, but they're like, I got to go soon, don't feel bad. Break away, we will record this. So I think the last section is around app-based QoS, if I'm not mistaken. And I think you're going to, or you've done a bit of a summary for us on that one, Jawad. So I'll hand it over to you.
Okay, thanks. Okay, yeah, this last section standing between us and lunch, so we'll try to be quick on this one. QoS, quality of service, yeah, depending on your background, you might have worked with QoS on like Cisco routers or WAN devices like Riverbed back in the days. It's becoming more important now with SD-WAN solutions or providers as well. The thing to note about Palo Alto being a next-gen firewall, this is an application-based QoS. So it's a policy match, and you can basically match on applications, which makes it basically very powerful and having that granularity and classification. So traffic arrives to the firewall unclassified, no specific order, and matches a certain policy. And the policy is gonna basically match to a class. So there's 8 classes in Palo Alto, and the classes correspond to priority, like real-time, high, medium, and low. And then you can set also maximum and guaranteed bandwidth through those classes. So use cases would be to provide priority for critical business applications over non-business applications, and potentially like throttle. What we've seen some cases is throttling like updates and streaming applications during working hours, but then probably opening more the pipe after working hours, because you can also set schedules on those policies. The 3 constructs or components of QoS will be the QoS policies that I mentioned. So you have to create that policy matching on source, destination, and most importantly, applications, and setting the class in those policies, and then defining the profiles, QoS profiles, which will basically have the classes mapping to like the priorities and guaranteed and maximum bandwidths. And then the third component is the QoS interface. So applying that QoS profile to an interface. So maybe you want to control QoS or do QoS just on like external interfaces, then you're applying it only on like the internet facing interface. The last slide is because QoS is best when it's end-to-end, like not just on the firewall, but end-to-end between the client and the server. Palo Alto has the capability to honor QoS markings from other systems like DSCP or others, honoring it as it's entering the firewall, and then keeping that or maintaining that mark as it leaves the firewall again. And there's DSCP is the most common one, and there's a few others that are basically configurable through the policy as well. So yeah, like you can set the EF if it's a high priority real-time traffic, or AF it's just high priority, and then or leave it as best effort. Yeah, any questions on QoS?
I guess one I'll jump in with, Jawad, is really seems like there must be such a common use case around streaming and throttling streaming, knowing
Oh, absolutely. Yeah.
it needs to be, it can't be outright blocked, but it's maybe not quite the same importance as some other critical traffic.
Yeah, some streaming applications, P2P, things like this could choke the bandwidth. I mean, end of the day, bandwidth is constrained or limited. And yeah, big use cases there to just throttle those streaming services based on you can do it through application filters and just throttle it to specific bandwidths during working hours again, mainly.
Right. Yeah. And a lot of those streaming services are so advanced that they adapt, and sometimes the users don't really notice that much of a difference in quality. So it's sort of a win-win in those cases.
Yep.
Awesome. Excellent. I think that takes us to the end. Thank you for covering that, Jawad. All right.
Yeah.
I'll maybe do just a quick rationalization on sort of what I took away from summarizing this. And during this time, jump in on the chat with any questions. I'll pause briefly to see if any of the rest of our team has some comments, and then we'll break here. When I looked at the items we were going to go through today, in my mind, I sort of divided them up into sort of three big buckets. There's a lot of aspects here in sort of bucket one, which is, I'll call it area of architecture fundamentals. So there's a lot of aspects that go back to just networking. And you might be an engineer that has a Cisco certification, and there's definitely some knowledge and some aspects that rely on this this foundational knowledge. That was one bucket. The other really is Palo Alto concepts. So not understanding the specifics, but understanding maybe some language or aspects around a Palo Alto concept, being able to identify and maybe making sure you understand those Palo Alto specific concepts is valuable. And the third really is getting into the specifics and understanding a Palo Alto feature, how it's configured. I think if you can find some way to get hands-on exposure for this element, we touched on that on the very first session. We're happy to take questions on and dig deeper on that. But that's really the third aspect. And there's a lot here. So maybe understanding the knowledge you have already across those three domains will help to understand where you need to focus to prepare for domain number 2. I'll pause briefly to see if anyone else has any comments, and then we'll close the call. Awesome. Thank you, everyone, for joining us. Thank you to our team. It was great to be at the virtual table with you guys this Friday, and I look forward to the next one. Have a good day.